good afternoon, good evening. Thank you for joining us today. My name is Brent Berenson, and I'll be the moderator for our presentation. I'm the director of Fluor's Office of Technology, which focuses on using science and innovative engineering technology to build a better world. Our engineers, designers, and experts, our people, are at the core of our success. As with other webinars, this will be a technical presentation. Today's webinar will be part one of a three-part webinar series on data-centric execution. Our subject matter experts this morning will talk about data-centric execution, why it's so important, and how it's an investment in the future as a company. We have three subject matter experts with us this morning. First, let me introduce Jan Willems. Jan is a Fluor Fellow in data integration, and is a Director of Project Controls at Fluor. He's currently the Global SAP Support Lead, Global Master Data Manager, and Tool Development Integration Lead on Fluor's Major Business Transformation Initiative. Jan has over 25 years of Fluor experience and over 30 years of global experience in project controls across various industries. With a strong focus on automation and integration, Jan has always strived to integrate people, processes, and data for optimization of project execution and in support of data-centric execution both inside the company as well as in the global inter-enterprise. Recently, it has culminated in the establishment of the Unison data standard, which Jan will discuss in detail during this presentation. During his free time, Jan dabbles in music, sound engineering and recording, and occasionally spends time in his wife's ceramics shop. Joining Jan Willems is Jan Anders Antonsen. Jan Anders is an integration specialist with more than 15 years of industry experience. He has spent the last 7 years in Fluor's information management group with a full focus on IT, security, data, and integration. Currently, Jan Anders is integration lead for capital cost forecasting and estimating for Fluor's PC&E project. Whenever Jan Anders gets time away from work, he enjoys gardening or pursues astronomy. Stargazing works well, as by the time he gets free time, stargazing is the only viable hobby. And finally, for today's health, safety, and environmental topic, which really sets the stage for our webinar today, I'd like to introduce another one of our project controls experts, Panna Sava. Panna has over 6 years of experience in project controls in the upstream and downstream sectors of Fluor's Energy Solutions business line. Panna is based out of Farnborough, UK, and is currently the change management coordinator on the INEOS NEP project in Grangemouth, Scotland. Panna was part of Fluor's data integration team and assisted with validation of reports from this initiative. Panna enjoys hiking and running in her spare time and has participated in half marathons. Panna, if you could please unmute your line at this time and share us the brief safety topic.
Thank you, Brent. The topic I have chosen to present today is around the topic of misinformation. And I'll start with some definitions. So what is misinformation? It is the false, inaccurate, or misleading information that is communicated regardless of its intent to deceive. It is not disinformation, which is false information intended to harm. It is also not malinformation, genuine information, again, with harmful intent. An example of misinformation in science is the tongue map of taste. There is a long-standing belief that the tongue can sense different tastes in specific areas of the tongue, and it is still widely believed, even if it has been debunked by modern science for a long time. So the issue with misinformation is the increased risk of being perceived as true information. It can then be used to make decisions, it can be passed on, and also communicated with others. And in many cases, it will linger around even after it has been corrected. At the end of the day, our decisions are as good as our assumptions, and there is a real risk that some of those assumptions are based on misinformation. Research has shown that information is easier to believe when it's made easier to read or hear. How many times have you made a conclusion because of something that you have seen on a PowerPoint slide? And how often have you believed the stats that you've seen in a presentation? Inaccurate information in our line of work can have varying degrees of consequences, from potential loss of profit to erosion of our safety culture to increased cases of safety incidents. We also tend to believe information when others around us believe it as being true. We can see this often in the workplace in the form of miscommunication. For example, acting on information that we've heard our team around discuss. So what can we do about this? We live in an age of unlimited information, and it is constantly competing for our attention, both at work and outside of work, and it has become a challenge to sort out and validate this information. The antidote is to reflect and to question the accuracy of the information that we encounter, but also to be aware of the issue of misinformation, to be aware that you and me and everybody else is prone to it and can be affected by it. Thank you, and I'll now turn over the presentation to Jan Willems.
Thank you, Bana, and indeed a very appropriate topic. As you will see in the rest of this presentation, information and correct information and how we use it is key in how we do business, especially in the world of engineering. What you see on your screen is a beautiful painting by the Belgian painter Pieter Bruegel the Elder. He painted the Tower of Babel, a biblical scene, a biblical story. Once he came back from his long trip to Rome and Italy, as you can see, the architecture really resembles the old Colosseum and the hills of Tuscany. But we're not here to talk about the hills of Tuscany, although that would be also a great topic. It's about the Tower of Babel. The Tower of Babel was, at that moment in time, the biggest engineering endeavor in the world. It was the most complex engineering effort by the best engineers with the best tools, with the best craftsmen available at that time. And the tower was going well. It was going all the way up into the sky, challenging the divine powers. And that's when the divine powers stepped in and made this little prank on our dear engineers and craftsmanship. Those craftsmen and engineers never, ever lost their abilities, but they got an extra gift, the gift of language. Not the gift of multiple languages that everybody could understand. No, each of them now spoke a different language. At that moment in time, work came to a screeching halt, because although they were still skillful and they were still great engineers and wonderful craftspeople, they could no longer understand each other or collaborate. They did not speak the same language. And that same problem we see when we talk about engineering. The same issue. In the world of engineering, in the world of engineering, procurement, and construction that Fluor has been in for more than 100 years, we have seen so many initiatives trying to tie together how all these different names of things are identified. And we call them codes. And we had the UN with the UNSPEC, we had POSC-CESA, we had the ISO 5926, CFOS, MESC, company standards, Fluor standards, project standards, no standards at all. You may notice that I highlighted CFOS because CFOS is not a code. You may have attended ONOPAB, our Fluor Fellow of Semantic Technologies and Data Interoperability. Fluor is really proud to have somebody like Ono who has been basically at the basis of a thing like CFOS. And CFOS is, as he explained in his webinar, a classification structure, not a coding structure. And that comes into play when we talk about the rest of what we're doing here. Also a beautiful quote on there, a quote from Umberto Eco, famous writer, Italian, polyglot, professor in different aspects of culture, philosophy, semiotics. In his book, Il nome della rosa, the name of the rose, he ends the book with this Latin phrase saying, Stat rosa pristina nomine, nomina nuda tenemus. The rose continues to exist through its name, yet the naked or pure name is all that remains to us. And basically, this quote tells us what our quote, our quest was for that naked name. that raw attribute of our engineering data. And this made us go into data-centric execution and Unison. First of all, what is data-centric execution? Data-centric execution is the pillar, as you can see, it is a pillar of Fluor's digital vision in terms of how we can execute projects in an innovative and cost-competitive way, still retaining Fluor's legendary execution excellence. Data-centric execution revolutionizes the way in which we handle project and mainly project data throughout the whole of the full project lifecycle. From estimating and bidding a job to all the engineering and procurement and subcontracting processes in between, up to the actual building of the facility, the handing over of the facility to client, and even the operation and maintenance of such facility. Data is the key in that aspect. So what is Unison? Unison is not a tool. It's not a system. Unison is a platform of approved data standards, supported by consistent work processes and by global governance. Unison allows us to realize that data-centric approach to how we do business. We apply standardized data from all different sources, current and past projects, tie it all together to make sure that we have a good view of where we are on the project and, most importantly, where we could be on the project. Unison powers also a lot of innovative systems and tools. And those systems and tools, they use that standardized data layer everywhere in all aspects of integrating information between the different systems. If people say that data is the new oil, data is the new gold, then basically the oil can maybe drive the machine, but in order to lubricate it, standardization of your information is key. So how did we do it at Fluor? Well, we didn't do it the wrong way. The wrong way, as we found out, and maybe so many of you also did, is to do it top down. It's very easy, and you will find tons of consultants around the world and tons of companies that will smack a beautiful graphical dashboard on top of everything you have. You now have all dials moving in different directions. Management is instantaneously pleased with those quick wins, but they are doomed to fail because, as Michael Hammer, who was basically the founder of Engineering the Business 25 odd years ago, said, building dashboards and analytics on top of bad data only advertises how bad your data is. So did Fluor do it this way? No, we didn't. We went the other way. We took the road less taken. For those people that know their Robert Frost, it makes all the difference. We started off with, and you may have seen the press notices come out about our initiatives with IBM on Watson and artificial intelligence and predictive analysis. We started feeding data into that environment and quickly came to the conclusion that our data is not of such a quality that it can be used by an artificial intelligence or any automated process without significant cleaning, without human intervention. That made us take a step back. In French, they say reculer pour mieux sauter, take one step back to jump higher. And we needed to build this foundation, a foundation of standardized data that results from a standardized work process. Why the standardized work process? Because we have to make sure that we're not putting excessive burden on people doing the actual engineering, procurement, construction work, that they have to type in lots of useless information, useless in what they may think is useless. So we built a solid foundation and a backbone for using attributes in classification. So where does that bring us? To complex data. And what you see here is probably one of the most complex data sets that you have in your body. The 2.9 billion base pairs of the haploid human genome correspond to a maximum of about 725 megabytes of data. That means, yes, you are no more than a single density 3.5-inch floppy disk. So don't get full of yourself. Also, your individual genome varies by less than 1% from other people's genomes. So losslessly compressed, you are roughly 4 megabytes apart. That is not even a song on Spotify. Still, those are very detailed and very identifying attributes. Nobody really can read them. And I know some of you may be geeks like everybody else and have an AT Thunderstroke GC t-shirt. And some people can indeed read that sequence, but a lot of us do not read the sequence of nucleotides and interpret it directly. We interpret the outcome. And what is the outcome? The outcome of that complex data is visible attributes. Your DNA sequence will drive how you are built. It will show the color of your eyes, the color of your hair, the length and the size of your limbs, your external gender attributes, so many things that we notice as individuals and we process. Because as humans, as our human mind is a classification machine, evolutionary built to quickly process tons of impressions and quickly make decisions on those. We classify based on those visible and identifiable attributes. This is how we talk about people, how we talk about groups of people, and how we look at people. We constantly scan, we look, we identify, we classify. Unconsciously, you're always doing that. And because you're doing it unconsciously, it's not always accurate, because it's driven by what you know and what your methods of classification are. You look at a crowd of people and you immediately make up your mind about who is who, at least for what matters to you. We do classify everything in our environment. We do it unconsciously, we do it personally. We do it based on our upbringing, our experience, and the world that we live in. Our classification, as Panna brought up in a HSC topic, is not always scientifically accurate, but we try. We try to classify the masses as we walk around. We classify children. So you don't need to go and ask everybody, what's your age, what's your birthday? They're children. We know this. We classify friends because we know, and maybe that is very surprising to a lot of people, but before Facebook, we did have friends. We did have mates that we met in the pub and we had fun with, and we drank a beer and played some pool or whatever. We classify friends because their image is stored in our brain. And we go like, hey, look, long time no see, how you doing? We classify toddlers as a class by itself or as a subclass of children. Yes, they are children, but they're of the smaller size. They're the ones you got to watch out because they bump into things, and you got to make sure that nothing is sharp or hurting in their area, because they will pick it up and do strange things with it. We classify men and women, preferably on external attributes, which again is one of the worst ways to do it. Me personally, as a kid, I had hair very long, so my dad got congratulated on a regular basis of having a beautiful daughter. We classify dangerous people. We look him in the street and see, oh, there's a guy with a hoodie. A guy with a hoodie must be dangerous, so therefore I now need to be afraid, and I already have to put all my feelers up because something's going to go wrong. We do all of that classification intuitively, and therefore it's biased and it's wrong. If we want to standardize and automate classification, we need to avoid errors, avoid bias, and avoid personal opinion. if we want to prepare data for the global processing of information and classification of data, we need to step back from the personal bias and take the personal bias completely out of classification. So we cannot use coding. Very obvious. Coding is the worst thing. First of all, coding is so 20th century. And secondly, coding is not reliable. What you see here is a dog. It's clearly a dog. It has a label on it that says dog. So therefore, it is labeled by somebody. It is a dog. You have nothing to say about it. This is a dog. Now, of course, you may think it's not really a dog because it smells fishy. Well, you may think that, but it's still labeled a dog. So what do? We can take different approaches. We can say like, okay, we're going to correct the coding. Somebody goes into the source system and overtypes the word dog with the word fish. We can develop an application which is built to say like, if label says dog and smell is fishy, then maybe transform this to fish, depending on if you want to. Or what we do in most of the cases, we dump the whole thing into an Excel spreadsheet, and then we do our thing on that spreadsheet without ever talking to anybody because you can't trust the information. And if it weren't for my spreadsheet, the whole company would be bankrupt. That doesn't work. We need something better than this classification. We need classification and not coding. The alternative, attributes. Let's bring in these attributes. By bringing in attributes of an object, we can start classifying objects based on a taxonomy. Taxonomy is a structure in which we classify these objects. We need these attributes, these agreed attributes that we know have agreed values, so that we can build a classification structure. Those attributes should also not be coded. They should fall out from a normal standard work process. Things that people do all the time and just produce the information. Otherwise, it's still another complex coding and people are going to still make mistakes. So what do we have in this case? We have a couple of attributes. Those attributes work fine. We now know it has 0 legs or 4 legs. It both have a tail. They got scales of fur. They get gills and lungs. They're cold and warm-blooded. We have a classification in place. We know the first thing is a fish. The second thing is a dog. All is fine. Nothing is wrong, or isn't it? Well, it may just be. Look at the 2 dogs there. Now we have 2 dogs because basically the attributes that we determined to do the classification were not sufficient to uniquely classify this object in the taxonomy. They are not exhaustive enough. This leads to confusion, and everybody that uses my classification routine will now see a black dog that hisses and a nice little furry dog that wiggles. So therefore, something is wrong. We need to correct those attributes. What do we bring in? Additional attributes. We need to make sure that the correct number of minimal attributes is defined. In this case, just for the sake of example, we added the sound that they make. One mouse, the other one arfs. By the way, they not only arf, they also do this in any language in the world. And I once sort of took an endeavor of finding out how many ways a dog can bark in different languages. But that's another subject, maybe a TED talk. It's also looking at what they do when they're happy. The cat purrs, the dog wiggles his tail. So now we have clear attributes. We know the first one is a cat, the second one is a dog. We again are successful. We again have classified, and we are ready to fully automate the world. Or aren't we? No, we aren't. Because you see somebody entered the word fluffy in there. Now, I know little kitty cat is fluffy. It is even adoringly fluffy with 3 exclamation points added. When people can enter attributes and attribute values that are not controlled and governed by data governance and data standardization, again, you potentially break your classification. Does that make us bound to standard codes that we will only use and never change? No. If fluffy is a good attribute value for skin, and everybody agrees that fluffy is a valid attribute, because you got to admit, if you compare the one on the side and then the little fluffy kitten, it is fluffy. It really is fluffy. Well, then your data governance process will say, let's add the value fluffy. Let's make sure it's included in the classification. It will now either say, yes, fluffy is a cat, or it will say fluffy is a cat. By the way, fluffy is also a subcategory of that cat. It's a kitten, and it's a really fluffy kitten. The moment you have that process in place, you can allow these changes in data to happen. You can be dynamic in the way attributes and attribute values change, but it's not going to break your classification. So dogs, cats, and fish on projects, what do? For us, they make that we can, for different clients, have different outputs. That while we are doing our business internally as Fluor with a set of raw attributes, we can select how we communicate to the outside world, whether that is a client or a partner or a supplier or a vendor. We can do this because we have these raw attributes, the naked name of the rose, basically. And those raw attributes are unchanging. They are universally known and accepted. And we can translate them in classifications to anything we want, including to client codes, if they still use codes, or we can feed the information as is in its rawest possible format, so the client or the supplier can take care of the raw data and use that without any coding in the way. So what does the concept of attribute-driven classification does for us? We're going to create multiple standard classifications for different purposes. We're going to classify objects based on attributes or a combination of attributes. We're going to store even those classifications as a separate attribute, so you can classify based on a classification, sort based on a classification. You can combine different, multiple, parallel structures that identify your unique piece, your object, based on all the unchangeable, unalienable attributes of that object. It allows for aggregation, for sorting, for filtering, for any kind of database action really fast. It's not just multiple classifications, but also multiple levels of classifications. Classifications are not single dimensional, they are hierarchical and multidimensional. So therefore you can have multiple taxonomies for the same object, depending on you are using the data, depending on the consumer of the information. And those multiple orders or levels of classification start at the detailed level, and then they go up and aggregate even more until you reach the top of the structure. And with that, we are at the part where it really starts to matter. And where it really starts to matter, I give the word to Jan Antonsen. Jan Anders, all yours.
Thank you, Jan. To use Jan's example, I found the actual dogfish. It exists. And talking a little about taxonomy, the smooth dogfish and Fluffy the fearless catus only share the top 2 ranks of the hierarchy, which is, amongst other important attributes, like having a spine. Luckily, smarter people have already defined it for us when it comes to the animal kingdom. But having this information gives us the opportunity to group and compare as we like. Things that we find natural can easily jump back and forth between, to generalize when we can and specify when we have to. Instead of fearless, the catus, we can just call it a cat, and everyone agrees on that. In the same way, we like to talk about our engineering quantities. Instead of saying a 2-inch ASTM A992, we prefer to say a small bore carbon steel. When the project manager comes to us asking how much pipe we have ordered on the project, we can choose the right level to report on, as defining the meters of pipe doesn't give a clear view of the whole project. The value of pipe changes drastically with size and materials. So small bore, large bore, over 30 inch. How about carbon steel or stainless steel? Even glass fiber. The list goes on, and depending on the final product, it can be made in high detail for the use in BI reporting with filtering capabilities, or in low details like a key quantity report where there are predefined classification standards that are common for the whole company. The options are there, and we have already defined the attributes needed to do this job. But where the scientists still argue about how to categorize the animal kingdom, we have already made it. By the way, Jan, the cat and the dog share the carnivore level, and only the top 4 out of 9 ranks are shared in the hierarchy. So we have already done the job making the classification, the standard classifications. So talking about the sizes, we have defined that instead of size 1, we say small bore. Instead of 15 inch, we say large bore. Instead of the ASTM standard classifications, we get stainless steel or carbon steel. All of our consumers can define their own classifications to fit with the demands from international standards, client standards, local standards, or even software standards, all based on the same sources and all traceable back to its original attributes. This slide shows a few examples of multiple different levels. It shows that with a unique detailed code and the associated levels, there can be multiple consumers using different rollups. For example, an estimator would be interested in material of construction, commodity type, and size, and providing quantities around above ground small bore carbon steel fittings will satisfy them. Your contract administrator, on the other hand, does not want to see these details. They are only interested in the scope split, so providing quantities around above ground pipe fittings and flanges which are in scope of contractor X will suffice. You don't need to provide material or sizing attributes. Some do not require an attribute to create a rollup. Some do not require a specific rollup as detailed code already provides sufficient context. Parallel classifications using all available attributes are, for example, pricing, effort hours, contract, BOQ, and key quantity analysis. So let's have a look at a direct example of a pipe and its pricing and execution responsibilities. Our pipe has a number of attributes, and yes, there are more than these attributes, as we just made a selection for today. And if there are any more pipers out there, they are probably familiar with the Trevin and Covin book that defines each attribute to details. And having all this data already in the system, we can define selections of the attributes which is needed for the different tasks we are performing, like pricing for estimating. As we are asking for prices for estimating stage, we have a selection of attributes enough to give us an estimated price for the material. Just enough to go out to the vendors to ask for prices back, but not too much to waste theirs and ours time over defining materials. Exactly enough for a good price, which we can then use in the estimate. Then we can pick the next group of attributes to help determine who will buy the equipment and who will install it. Is it company that is buying and contractors installing? Are we buying and installing ourselves, or will contractor 1 split the installation job with contractor 2 by area? With this, we can then add some general attributes applicable for all types of material, which combines with the default piping attributes gives us enough data to split the responsibility by a set of predefined rules. This also allows them to keep the estimate alive during the whole engineering lifecycle, resulting in a solid forecast every time. They can generate a standardized bill of quantities to attach to a bid, all standardized by the book every single time, eliminating the use of spreadsheets. To talk further about how these attributes can be used in the future of contract management, I will hand it right back to Jan.
Hey, Jan-Anders, thank you very much. And that really brings us to what we do with this. And as Jan-Anders and I can testify, we can talk ages about this. Ages about how we spend all the effort in getting this together. We got to do in 1 hour what we spend a good 5-6 years of our lives on. But we can do this because we're passionate about data. So what happens here is, what is this going to do for the future of contract and subcontract management? And I really put the sub between the parentheses, because a company like Fluor is in the middle of a B2B2B scenario. It's not just business to business. It's a client that gives us a job to do, and we communicate with our vendors, with our subcontractors, getting information from them. They sometimes even participate in design, and they bring that together and then give it back to the client with a finished facility. So by having this material identified, by having the tasks unified, by having all of these attributes available throughout engineering and design systems, throughout the whole supply chain, throughout everything we do in construction, we now can standardize how we exchange information. We have a bill of quantities. We have a contract plant handover. We have reporting. We do all of this not based on coding and recoding or hard coding of client project specific codes during execution. We drive it by attributes. By having it driven by attributes, it becomes universally applicable. It becomes interchangeable between clients and contractor. Jan Anders was bringing up the small bore, large bore split. And yes, we all agree that 2-inch is the cusp for small bore pipe. But some of our clients, mainly in the mining world, they say that small bore is 3-inch and below. We're not going to change the way we code, hard code, small bore and large bore pipe. We're just going to classify it differently. We classify to codes or identifiers when we need. If clients have systems that still need to rely on hard coded values, we can do that. But if clients, like more and more, start working with raw data, we can provide highly clean information. When we started on this endeavor, and I was saying 5 to 6 years of our lives, we all looked a lot better before that, but we were maybe less happy because we did a lot. 5, 6 years ago, when we started the whole endeavor of data-centric execution, the situation in the engineering and construction world was fairly dire. I mean, McKinsey had this report produced for us, and it showed that construction, apart from energy, was at the bottom of the class as far as it comes to spend on IT or R&D. Engineering output per hour was lagging any other industry. Construction productivity was flat or even decreased over the last 40 years. There was limited focus and no consistency of data, and there was a lot of challenges with project predictions and reliable outcome. To us, when we read this, and this is industry specific, it applies to us and everybody else, it almost goes back to that story of the 2 shoe salesmen that get sent to an island. They observe that on the island, nobody is wearing shoes. One sends a message to the headquarters and say, nobody's wearing shoes, waste of time. The other one sends a wire back and say, nobody's wearing shoes, great opportunity. We saw this as an opportunity to differentiate and start to take a head start on what to do with our development of our backbone of data-centric execution. And in the modern day, the last year after COVID, I mean, we heard it so many times, companies spend 10 years and countless consultants on coming up with a digital strategy. And then on March 14, 2020, everybody had a digital strategy within 24 hours because they had to, because the world went into lockdown. We were working remotely. People saw all the benefits of data integration, of identification, of sharing information, and the spend will go up. If you look at the global data survey results, it is seen that a lot of companies will start investing massively post-COVID in the next 5 years on automation in their construction and construction industries. So we're happy and we're good because Fluor took a head start. We built a solid functional foundation of our data standards and work processes. A solid standard, because that solid standard basically is the foundation of that stack of what is Unison and data-centric execution. A data standard is something you stick to. A work process makes sure that everybody follows the same process to generate that data in that standard. Data governance allows us to actively change, modify, update, and control that standard and be adaptable to market changes and be adaptable to anything else. We also build a solid IT foundation, a solid IT infrastructure with a embedded philosophy for sharing information, for interfacing large volumes of data. And if you want me to go wild again, just ask me to talk about ODS or operational data store, ETL, EDM, and data marts, and we'll have another presentation on our hands in no time. A solid foundation with common data structures and large volume data allowed us to build automated tools. And the actual final outcome is automated tools that process this data, store data in its rawest possible, very controlled form, allows us to start doing real analytics by using classification, semantic layers, reporting, and analytics. The outcome of this foundation is what you will also see in the upcoming presentations. There are 2 more presentations in this series that really build on this foundation of data-centric execution and take it to the next step. You may also have attended Peter Paul Pruin, our Senior Fellow of Information Management presentation on the digital twin, also working basically on the same basis, the same platform of that data-centric execution. You may call this a cheating, but at Fluor, we're kind of mavericks. We just call it thinking outside the box. By just drawing the lines a little bit outside of where we thought everything needed to be, by thinking further than just the codes we were used to see, we build a very strong data-centric foundation. So with this, I thank you all, and I'll leave it back to the moderators.
Okay, thank you, Jan. Let's take a moment to address the questions that have come through the chat thus far. And again, as a reminder, please use the Q&A function in WebEx and make sure to address your questions to all panelists. Okay, the first question is for Jan Willems. Can you tell us something about the software stack you use for classifications and master data management?
The technology that we're using generally is the Microsoft stack. So it is most of Microsoft projects, starting with SQL Server as the foundation. We use SSIS, integration services, for all the ETL and data transfer. BizTalk as another data integrator. We use SSAS and SSRS for reporting and analytics. The master data that we have either comes from a source system, if the source system is the system of record, like for example, employee data comes out of our ERP system, SAP, engineering attributes come out of our engineering and design systems, and they are coming into our shared environment already vetted and validated. But information that we did not have a home for, that did not have a master data source, we using Microsoft's MDS solution, which is a very simple but very effective master data management tool to make sure that we get the data structured correctly. On the side of the consuming side, we see something else, of course. We see prototyping going on with semantic layers, and we have some very interesting work going on there in our Amsterdam office to take information from this vast pool of detailed attributes and turn it into true semantic analysis. So there's a lot of very interesting things going on.
All right, thank you. Next question is, have you completed this attribute classification work to date?
There is a golden rule that says great work is never done. And I try to say it's a living standard. So, but Jan-Anders has been very intimately involved with this day-to-day work. So maybe you can answer that question, Jan-Anders.
Yeah, sure, Jan. I would like to say yes, we have done the job and it's already there. And we could say that to a certain level because we have already done a huge job. So the projects can choose to use this one. But I think we need to agree on that this job will never be finished. First of all, because all projects are different, all clients are different, and all engineers are different. So we will most likely continue doing this job for a long, long time. But today, at least, we have a package that we can offer to everyone that we can start with, and that's available.
Okay, thank you. Next question. Is it manageable to do this on all types of projects, large and small, for example, sustainable capital projects?
I will take that because my roots with Fluor before working for BP Chemicals and a Belgian engineering company were in the south of the Netherlands, where we have a very small and very nice office, Bergen op Zoom, that did all small projects. And I always have a sort of a Bergen op Zoom litmus test in my brain whenever we develop something, whenever we do something, to make sure that it still works. Yes, it will work on small projects, because even small projects have the same level of detail. If you're needing to replace 2 pumps with some lines and some foundations, yes, you will not have 1 million lines in your estimate, but those lines in the estimate will have the same attributes. So therefore, this Unison works even on small projects. I would say it works even better on small projects because you can more quickly play on the actual estimate to engineer to execution to completion cycle.
Thank you. What was the basis for your data standards? Did you use an industry norm or standard?
I think we used many standards. And again, this is going to be a split question between myself and Jan-Anders. I will talk, for example, about things like a chart of account structure and all of these things. Those were really based on input from various industries, AACE, ICE, all of these standard bodies of knowledge that we have that helped us structure the information. For the detailed data, you saw that in Jan-Anders' slides that he was referring to the blue book. So therefore, I think Jan-Anders, for those attributes, we have relied a lot on the available engineering standards.
Yes, and of course we have been working with the standards out there, and there's no going around that. Those are the ones that's ruling our current work area. We have, of course, made this our own. So there are standards that we have built within our own system to make this happen. But we have what we currently have can be covered by all the standards, standards out there. That's a nice word.
Okay, thank you. Next question is, what is the reception of data standardization at Fluor? So Unison, as an example, with our clients and perhaps our vendors and subcontractors.
I can recall some stories of our functional lead in project controls talking to some of our main clients, and they go like, it's about time. And so basically, a lot of our clients are also thinking in the same structure, in the same details. That's why an initiative like CFOS is successful and taking ground, where before every company was still almost implicating that their standard would be the standard. And if I work for client A, I have to use client A standard. If I work for client B, I use their codes. And we always were mapping. I think everybody starts realizing in a full digital economy that this is the way to go. Is this something where we now go to all of our clients and then the red carpet rolls out? No, we still have a lot of convincing to do because it still needs to grow. But as I said, we have the foundation. And from what you will see in the following 2 webinars, you see the practical application of those is really what's going to make our customers think twice and really think about joining teaming up with Fluor to do their projects.
All right, great. Next question. How is Unison implemented in joint venture projects?
That's always a tricky one. You can do this because a joint venture is basically an agreement between two partners, and you agree on standardization. A typical example is if you have shared design between two joint venture partners, you agree on a joint seed of the engineering and design environments. If you have a joint seed file to your design environments and you have design data that therefore uses the same attributes and the same attribute values, this works perfectly. If, of course, we are bound to be like a subcontractor to a leading partner imposing their design standards on us, at that moment in time, it will be up to that design partner to fully report everything. And as that happens, everything depends on the structure of the joint venture. So there is always an option. It is even more than before, where we always kept saying, before you start a project, think, align, sit down together. It is even more important in a data-centric world. In the past, as I said, with the dogfish, you could still take it all into a spreadsheet, change the codes, and that was it. Now you had a couple of hundred lines to update with the global search and replace, life would be good. The problem is we're now talking about millions of lines of data, detailed information of the whole engineering and design process. That is not something you dump into a spreadsheet. So you sit together with all the parties. If it's in a normal project that we do execute exclusively, or one where we have a partnership with a design build contractor, or one where we have a joint venture partner in either a mix or in a segregated joint venture where the partner takes one part of the scope and we the others. We always have to align. That whole alignment and collaboration becomes more important in the digital world than it ever was in the analog world, because we can only start the project once, and we better start it on a good footing.
Absolutely. All right, thank you. Next question. Has the Unison solution been proven in the sense that it's been used on real projects in home office and field?
Well, given the current market situation, we have not too many projects globally executed everywhere, but we have a lot of projects using Unison to do the cost management, services cost management, and everything else. And I think, Jan-Anders, you have been heavily involved in a couple of the capital cost estimating initiatives that start now to see the benefits of the engineering attributes, huh?
Yeah, absolutely. And what we are doing right now, of course, is running this on a couple of pilot projects. And this is already showing that with the standardized solution that we already have now, it makes it a much easier way to actually get the estimate correctly, quickly, and also to respond to changes during the estimate much quicker. So absolutely, this is something that we are currently working on, and it is out there. And for all I can see, it is working.
And very important to add on to that, Jan-Anders, is also what you said in your presentation. We are keeping the estimate alive. The estimate is no longer a one-time event you do during proposal. It's something you almost do on a monthly basis to challenge your outcome on a constant basis, to make sure that you observe your quantities and your price modifications as they happen, and you don't get blindsided the moment we hit the field. I mean, I started my job in construction and had to learn home office engineering after a while. For us, it was always the eternal battle. The float was eaten before the field was reached, and we want to avoid that.
All right, thank you for that. Have time for a couple more questions. What impact do you see the data standards have on vendors supplying information and feeding Fluor systems?
As I was bringing it up with the standard integration with our suppliers, whether they are supplying goods or services, is the better information we can provide to our vendors, the timelier we can provide information to our vendors, the better. Again, one of the typical scenarios that we have is we go out for bids to a subcontract with preliminary engineering information. We don't bother to resend information until after we have an award based on the pricing and everything else. The information received by the contractor is not the same as what they bid on, resulting in potential claims, delays, and everything else. By having a data-centric solution, we can regenerate that request at any moment in time with the most accurate, up-to-date engineering data. Will it be perfect? No, because we're still engineering, but it will be nearer and nearer to perfect. Perfect is an asymptotic curve. You never get there, but we can get a lot closer than doing it once and then hoping for the best. So that is where we will see a lot of benefit for ourselves, because we will have less rework, we will have less bothersome meetings with clients to apologize and vendors to get mad at us. For our vendors, because they will have a very much better working relationship and they have all the information. And for the clients, most important, because they have a predictable outcome of their project.
All right, thank you for that. I think we have time for one more. How does digital twin relate to all of the classification work that's being done?
I think digital twin is the next step from what we do. This is the foundation to allow data interchange. And I don't know, Jan-Anders, if you have anything to add on what you had as experience before. And of course, there was Peter Paul's presentation before.
Yeah, no, I think you're right, Jan. Having the standard, and this is also the answer for a lot of the other questions that we have gotten asked today. Having the standard makes it easier for us to start anything, whether it's the digital twin, whether it's getting prices in from vendors, or whether it's starting a new project with a PJV. So having the standard already here, and we have this as a starting point, makes it easier wherever we're going from here.
All right, perfect. Thank you. And it looks like that's all the time we have for questions today. Thank you again, Jan and Jan-Anders, for this interesting discussion. To our audience, we appreciate your attending and for your engagement today. It's been a pleasure being your moderator. Thank you for joining us. Catch part 2 of our data-driven discussion series on Thursday, September 23rd at 10 a.m. Central Time. The registration link will be posted on fluor.com shortly. Please continue to stay informed of these events by visiting the Innovation Builders page on fluor.com or following our social media channels using #InnovationBuilders. If you'd like us to send you email notifications of future webinars, please email us at innovation.builders@fluor.com with opt-in in caps, and there's a hyphen between the opt and the in the subject line. We appreciate your attention and thank you again for dialing in today. We'll send out a recap email with a compiled list of the Q&As and a link to the webinar recording at fluor.com within a few days. If you have any questions or require additional information, please email innovation.builders@fluor.com and someone from our team will get back to you. From all of us on the Innovation Builders team, have a safe day.